Hi, this is John. Here's my Project 2 case study. So my main goal for Project 2 was to create an animal detector. When I was first given this project, I came up with three different ideas. The prank box by using the LED, stirrer by using a servo model, and then it's an animal detector by using a pin sensor. After pondering, I decided to go with the animal detector as my idea. I choose it because the animal detector can really help the user to solve some problems, some real problems caused by the animals. The animal detector is meant to detect the movement of animal and prevent animals from entering our home. So here's a brainstorming. After I came to Canada, I found one thing that's very different from China in Canada. There's so many wild animals around, such as squirrels, raccoons. I rented three different places in Canada so far. And the owner of each house would always tell me to make sure keep the garage door and the garden door closed, or the critter would sneak in. This animal live around us, and normally it's peace. Normally animals won't like cause us any trouble, but it's very different when they sneak into our home. For example, like slightly large animal like raccoons will sneak into our home and sneak into our garage and tip the pin hour. Also, if they stuck in certain spot, owner might pay extra for professionals to get them out. There's thing that happened recently. I was running and happened to see a raccoon sneak into my neighbor's garage. I thought to myself that the owner of this house is going to clean a mess tomorrow. So all this stuff turned into inspiration for me, and I thought I could design stuff. I could design a product to solve that. Then here's the visual research. It's crazy thing is there's two image. It's I borrowed from my friend. No, it's really happened to his house. Mainly I search and the search. Well, so mainly the visual research is I search some animal sneak into human's house and cause some trouble on that. So yeah, we still using feather. But if from project one, it's kind of different. Instead of using Adafruit IO, we use the Thinker IO. But the principle is much same as before to interconnect the Arduino P5JS and the Thinker IO by Wi-Fi. Personally, for me, I think Thinker IO is easier and more it's useful and more convenient than the Adafruit IO. So Thinker.io does not need to write too much Arduino code. It just need to make sure these two tools are connected. So it can be programmed in Arduino, of course, and then connected to the Singular.io for data update. Singular.io allows the user to create the widgets. As long as we make Arduino and the Singular.io are connected, we can create different widgets in the website of the Singular.io to control the electronical stuff on the breadboard. Connect from the Feather. For example, adding the switch to control the LED on and off, and adding the progress bar to see the data updated by the pin sensor. All right, here's the system map. Basically, is how the progress of how to connect these things. Here's the diagram. So for the circuit, I combine the circuit from the LED one with the pin sensor one. I initially used the advanced diagram, and I also removed the pin 12 and the LED on the breadboard as the professor told on Teams. However, it seems like it doesn't work on my laptop. I don't know why, because every time I connect the USB pin, try to get the 5 volt, my laptop will showing a error message. It's saying too much voltage spike. It's because my laptop's USB slot to cut out, which is why I use 1K resistor to reduce the voltage spike. here. Here's Arduino code. So I combine the pin sensor Arduino code with the LED one. So here's sending data to the single IO. So after we set everything up, we finish create a widget in website of single IO. I was able to connect Feather to the single IO and use the button on the single IO to control the LED and see the pin sensors data is progressed in the progress bar on the website. So after that, all we need is copy the URL and the connection key to the P5. So here's the P5.js code. So all I want is create a radar, and then the red circle in the website are displayed in relatively position based on the pin sensor sensing of the distance. I'm editing the code based on the code of advanced the pin sensor P5. I primarily changed the movement of the circle. The primary code was width 3, height 2, the bubble. First, I replaced the height with bubble, which can make the circle move from top to bottom according to the data transmitted by the pin sensor. However, it can only move in the straight line, and I wanted to move left and right. I realized that it probably needs at least 4 pin sensor to achieve that. So I don't have that much, but still, in order to create the vibe of animal moving, so I found out another way. I added the random function to complement that. So here's a sketch, some concept sketch. So after I came up with some idea, I trying to design the stuff, and based on this feature, I created some concept sketch right here. And then and then it's modeling. I use Rhino to build the whole stuff. So in order to make more realistic, show the usefulness of the product, I used the blender to add some color, just render it out. And I also added the theme, so I want like better inform the user about this product. So here's the UX in storyboarding. So there's like 6. I mean it's like an instruction of how this animal detector work. So on the first one, the user need to install the animal detector in the place where animals are often found. I suggest on roofs, gardens, and garages. Then on the second, it's turn on the switch and make sure everything is connected. The animal detector then will start working. The third one, when the animal approach, the animal detector can detect the movement. Next is as soon as the animal detector found the animal in approach, it sends the data to the computer. The computer screen will show the location of show the distance of the animal. So once the user is aware of the approaching animal, he can open the Single.io app or website of Single.io. In the app, the user can just check the distance data, and if the user found out it's really close, the user can just turn on the high intensity LED on the top of the animal detector. So when the LEDs turn on, this LED is kind of a high intensity LED. The light will like flash and just chase away of the animal. So after an animal will drive the way, the animal detector will keep working, just like detect those things. Here's a Single.io app. So it's kind of really easy to use. I mean, like just download the single IO app, then connect to the source resource. It allows user to remotely control the LED. Just control the everything you want if you set up on the breadboard. Here's my final prototype. So for my final prototype, I went through a couple new guides to understand, and then the three tools. Between the three tools, Arduino P5.js and the Sync.io, interconnected by the Feather. Project 2 is an advancement compared to the first one, as we were required to do both, like physical computing and we need to come up with some practical idea and concept of the product. So in this project, we are experiments with the Sync.io app on our phone to control the electronic of the on the breadboard. I'm really getting to it because I was interested in the smart furniture. I think these things allow us to make the smart furnitures. So I'm looking forward to knowing more, explore more ideas with this tool in the future. And here's my link to my Arduino code and P5.js code on my GitHub account. So I pre-record the video. It's showing how this prototype work. All right, let's see how it's work. Hi, this is John. This is my project. So on this project, we mainly focus on developing the principles and the knowledge developed in Project 1. There's connecting physical computing to the Wi-Fi. So I made a product called Animal Detector, and I made it to help users solve some problems caused by animals. The animal detector mainly detects the movement of the animal and prevents them from entering our home. So let's see how it's gonna work. So the red dots on the radar will change its position according to the data received from pin sensor. So we can see here. So the closer to the pin sensor, the closer to the white circle at the top, and in the similar way, further away from the pin sensor, the red dot will further away from the white circle. So why I do that? So I want to represent that it is used to show the exact position of the animal also on the Sync.io website. We also can see here there's a progress bar. It same shows the data received by the pin sensors. So closer it's gonna decrease. Further away, it's gonna increase. So this button also works. When I press it, the LED is on. All right, this is my project. All right, and then here's my reference. I just cited everything. I use it. All right, thank you for listening. This is my project 2.